Okay, for this video, we are going to recap all of our biochemical tests. Now, you did a lot of these at GCSE, and there's a couple of extra bits that we've got to cover for A-level, like the test for a non-reducing sugar, and also how we can make the Benedict's test fully quantitative. So hopefully you're going to find this useful. The first thing that we're going to do is go through and do a quick recap of each of the biochemical tests, what reagent that we use, the different steps of the method that we need to include, what the negative result would be, so if there was none of that molecule present, and what the positive result would be, which is often a colour change. So let's start with the test for a reducing sugar. Now, reducing sugars are all of your monosaccharides, so glucose, galactose, fructose, but also the disaccharides, maltose and lactose. Now, the reagent that we use for this one is Benedict's reagent. Okay, so we'll write that down first. We add Benedict's reagent or Benedict's solution. You don't have to worry about volumes. I mean, you can say 2 centimeters cubed if you want to, but you can just say add the reagent. So you're going to get the mark for naming Benedict's reagent. Second step is really important. We must say and heat. Okay, don't just say put in a water bath, because a water bath might be cold. You might have it set at, say, 20 degrees. You've got to heat it in a water bath. If you are going to give a temperature, I would give a temperature between 80 degrees Celsius and 100 degrees Celsius, but you don't have to give a temperature. You can just say heat it or heat it in a water bath. And that's your 2 steps. Now, the negative result, if there's no reducing sugar present, then the Benedict's reagent would stay blue. But if there is reducing sugar present, you will get a red precipitate. And it is a precipitate, so that is important. It's a solid that forms in the solution. Now, the concentration of reducing sugar will affect the overall colour, because if you've got a high concentration of reducing sugar in your solution, you'll get a lot of red precipitate, so it will look like a brick red colour. But if you've got a lower concentration of reducing sugar, it will look more orangey or yellow. And some mark schemes do give you credit just for giving the colour, just for saying it goes red, it goes orange, it goes yellow. But the best way to guarantee the mark is to say actually it forms a red precipitate, because that word precipitate may be necessary to get the mark for the positive results. Let's move on to the non-reducing sugar. Now, the non-reducing sugar that you guys should know is sucrose, which is a disaccharide made out of glucose and fructose. Now, what you would do if you had a solution and you thought it might be a sugar, you would probably do the test for the reducing sugar first. So you'd probably add your Benedict's, you'd heat it in a water bath. But if it didn't form that red precipitate, then you might want to check to see, well, it's not a reducing sugar, maybe it's a non-reducing sugar. So after you've done that initial Benedict's test, you would go on to complete these steps. So the first thing you would do would be to boil with an acid. Now, you can just say acid or you can name an acid. So we usually use hydrochloric acid. Then you need to neutralize with an alkaline. Now, again, you don't have to name the alkaline solution that you use, but you might say use sodium hydroxide or sodium hydrogen carbonate, something like that. But you don't have to. You can just say boil with an acid and then neutralize with an alkali. Then, once you've neutralized it, then you can add the Benedict's reagent. Oh, spelled Benedict's wrong there. So then you can add your Benedict's reagent, and again, you would have to heat it. Okay. And then if there's a non-reducing sugar, that will have basically hydrolyzed the glycosidic bonds. It will have hydrolyzed the glycosidic bonds in the sucrose. So you'll now have glucose and fructose, and now it will give you the positive result. So the negative result, again, would be blue because you're using Benedict's reagent again, which is blue. The positive result would be a red precipitate. But you're only going to get that positive result with a non-reducing sugar if you've boiled it with acid and then neutralized it with an alkali, then done the Benedict's test where you add the Benedict's reagent and heat. Test for starch, you add iodine solution. And it is important to let the examiner know that it's iodine solution or drops of iodine, because you're not going to be plonking on like a lump of solid iodine, okay? So add iodine solution. Now the negative result, obviously iodine is orange, or you can say brown, or they'll accept yellow. But if starch is present, we say that it goes blue-black. And this is a nice simple biochemical test because you don't have to heat it or anything. You literally just put some drops of the iodine solution in, and if starch is present, it will go blue-black from orange. Protein is another nice simple test. You just add Biuret reagent or Biuret reagent, which is basically a mixture of copper sulfate and sodium hydroxide. So you might, in school, you might have Biuret A and Biuret B, but it's just copper sulfate and sodium hydroxide, or mixed together. We call it Biuret reagent. Negative result, well, it starts off blue. It's a very light blue colour. If you've got protein present, so maybe you've got an enzyme or something, if you've got protein present, the positive result will be purple, or you can say lilac or mauve. I don't know who's saying mauve, but it's always on the mark scheme. But yeah, just purple is fine. Finally, the lipids. Now this one is called the emulsion test. Now the only kind of tricky thing with this one is to remember that you have to add two reagents. So you add ethanol and water, and you have to add them in that order. So you add ethanol, then water. And you do need to shake it. So you could say add ethanol and shake, then add water and shake. You can just say add ethanol, then water and shake. But you do add the ethanol first, because this is what's going to dissolve the lipids, okay? So it can form the emulsion. So you add ethanol, then you add water, then you shake it. Don't need to heat it. It's quite simple as long as you put the ethanol first, then the water. The negative result, I suppose, for this, we would just say, well, let's do the positive result first, really, because the negative result, we just say you don't get that positive result. So the positive result for the emulsion test, so if lipids are present, we'd say that we get a milky or a white emulsion. The word emulsion is important. We're not just going to say it goes cloudy, because that's not good enough. We're going to say it's a white emulsion or a milky emulsion that forms. So in terms of the negative result, you could just say no white or no milky emulsion, okay, if there's no lipids present. So that's your basic biochemical tests. As I said, make sure you know the name of the reagent. If there's any other steps in the method, like do you need to heat it or boil it or neutralize it, make sure you know the negative result so that you can say the color will change from this to this. Or in the case of the reducing sugar, you can say, it will go from blue to the formation of a red precipitate, or for protein from blue to purple, just in case. So once we've got our biochemical tests, I wanted to just add on a little bit more for A level. So let me show you this. When we do the Benedict's test, whether this is for a reducing or a non-reducing sugar, as I said before, you can get different colours based on the concentration of reducing sugar that is in your solution. And if you get a lot of red precipitate, it will look brick red. If you get slightly less, it will look orange. If you get even less, it will look yellow, or maybe even a bit green. So you get this kind of range of different colours based on the concentration of reducing sugar or non-reducing sugar. Now, what we say about the Benedict's test is that it is semi-quantitative. And what this means, you're not getting numerical data for the concentration of sugar. So it's not fully quantitative. You're not going to get the actual concentration. But what we mean is you can get an estimate for the concentration of sugar, whether that be reducing sugar or non-reducing sugar. You can get an estimate, because if it goes brick red, then you know there's a higher concentration of reducing sugar. If it goes orange, there's a slightly lower concentration of reducing sugar. If it goes green, you know that there's some sugar, but there's a very low concentration. So it's semi-quantitative. It's not numerical data, but it can help us to estimate the concentration. And what we can do if we've got, say, an unknown solution that contains glucose, a reducing sugar, but we don't know the concentration, then what we can do is prepare a dilution series for glucose with known concentrations. Okay, so you'd prepare a range of different concentrations that you know, maybe 5 different concentrations would be a good range of different concentrations to use. On those known concentrations, you can then carry out the Benedict's test, which obviously means you add your Benedict solution and you heat it in your water bath. You can then observe the colours. Yeah, and you probably note down the observations. What colours have those known concentrations gone with the Benedict's tests? Then you can test your unknown concentration in the exact same way. So what I mean by that is, you'd have to use the same volume of sugar solution. You'd have to use the same volume of Benedict reagent so that you can actually compare your unknown concentration to your known concentrations. So test it in the exact same way. Obviously, then you can observe the colour that your unknown solution has gone following the Benedict's test, and then you can compare the colour. So compare the colour of your unknown solution to the colours of your known concentrations. So if your unknown solution that you didn't know the concentration of went orange, then you can compare that to the orange tube from your known concentrations, and obviously it's the same concentration or roughly the same concentration. If it's gone red, then you can compare that to your red tube from your known concentrations, and then it's roughly the same concentration. Now, again, this is not quantitative because we are still estimating here. So this is a semi-quantitative measurement where we take a range of known concentrations, carry out the Benedict's test, observe the colours, then we carry out the Benedict's test in the exact same way on our unknown concentration so we can compare the colour to our colour standards, if you like. Now, how can we make this fully quantitative? I'm just going to suggest a couple of other methods that you might come across in A-level biology. So if we want to make the Benedict's test fully quantitative, we want numerical data, there's a couple of things that we can do. So we could carry out the Benedict's test on our solution, whether that's a reducing sugar or a non-reducing sugar. Then, once we've done it, we could filter out the precipitate. Okay, so let's say we carry it out on a glucose solution. There is glucose present, obviously, so we get red precipitate. We could filter out the precipitate, then dry the precipitate, then weigh the precipitate to find the mass. Yeah, and we could do that for a range of different glucose solutions so we can get quantitative data for the mass of precipitate so we know more about the actual concentrations of these solutions. The other thing that we can do is use a colorimeter. Now, a colorimeter measures the absorbance of light by a solution. In fact, you can also use it to measure the transmission of light. So you can use a colorimeter to measure how much light gets transmitted through a solution, or you can use a colorimeter to measure how much light gets absorbed by the solution. And you put your solution into one of those little cuvettes. I don't know whether you've seen them, they're quite cute. Cute little cuvettes, which are like little rectangular plastic containers. You put your solution to be tested into the cuvette, you put it into the colorimeter, and you can measure either the transmission or the absorbance of light by that solution. We tend to use the absorbance, or at least that's what I always used when I was teaching this in schools. But yeah, it measures the absorbance of light. So what you can do is, if you've got, let's write an answer actually for this one. You could take let's say 5 different concentrations of glucose. So you use a dilution series to create 5 known concentrations of glucose. Okay, so you've got a range of concentrations of glucose solution and you know the concentration. So these are going to be our standards. Then you'd carry out your Benedict's test. And again, the Benedict's test is where you add your Benedict's reagent and you heat it. Then you'd place your samples in the colorimeter and record the absorbance of light. Okay, now you could then plot this on a graph. Now this is the kind of graph that we call a calibration curve. So I'll do you a quick sketch of one. So on the x-axis, we'd have our concentration of glucose, which we would know because we've prepared these concentrations ourselves using a dilution series. So you'd plot that on your x-axis because that's what you've changed. So that's your independent variable. Then you'd plot the absorbance of light on your y-axis because that's what you've measured. So that's your dependent variable. Obviously, you'd put your units. So concentration of glucose, it might be percentage, it might be moles per decimeter cubed. Absorbance, it might just be arbitrary units. You can look on your colorimeter. It might be measured in what we call absorbance units. So you can put that onto your y-axis. And then we can actually plot our calibration curve. And you should end up with something that looks kind of like this. So as the concentration of glucose is increasing, obviously you're going to get more red precipitate forming in the solution. And the more red precipitate or red solid is in that solution, the greater the absorbance of light. Because if you've got more solid precipitate in there, it's blocking the light from getting through or more light is being absorbed. So that would be your calibration curve. You do need to understand what that is and even how to plot it. So the concentration of the solution on the x-axis and then the absorbance, which you've measured with the colorimeter on the y-axis. You can then use this graph to find the concentration of an unknown solution. So if you've got an unknown solution which contains glucose, but you're not sure of the concentration, you carry out the Benedict's test in exactly the same way. So you add your Benedict's reagent, you heat it, but remember you would have to use the same volume of the glucose solution as you used before, the same volume of Benedict's as you used before, because you do want to be able to compare this tube to your other tubes, okay? So you carry out the Benedict's test in exactly the same way, controlling all the same variables that we discussed. Then you'd use the colorimeter and you'd use the same filter, the same color filter in the colorimeter, for example. So use the colorimeter, record absorbance, and then, and this is the clever bit, because you've got your pre-drawn calibration curve that you constructed using your absorbance values for your known concentrations, once you've got the absorbance value for your unknown concentration, you can find it on the graph. You can draw some construction lines. So draw across and down, and you can actually determine the concentration of your unknown glucose solution. So you'll get a numerical value, you'll get quantitative data. Okay, so both of these methods here are about quantitative data, which is always going to be more accurate, right? We love quantitative data in science. So we can filter out the precipitate, dry it, weigh it, record the mass, so we can compare concentrations, or we can use a colorimeter to measure the absorbance of the solution after the Benedict's test. And this is one of the required practicals you're going to have to do, where you actually construct a calibration curve from your known concentrations and use it to find the concentration of an unknown sugar solution. And I hope you found that useful. Obviously, watch this video as many times as you guys like. You can go back to the start of the video where we go through the basics of the biochemical test for A-level biology. And then we've also discussed quantitative methods for the Benedict's test and why the simple Benedict's test is described as semi-quantitative. Make sure that you're subscribed so that each week you get a notification. Yeah, turn the notifications on. I think that's what you do. Because we will be posting videos like this each week, and we'll also be going live every Friday where we're going to be doing revision of A-level topics, whatever you guys want to do, whatever you suggest, we can do that as well on a Friday. Thanks so much, guys. See you next time.